We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRAE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRAE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRAE helps formalize industry codes and standards. ISHRAE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRAE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRAE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRAE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, ICREX India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision-makers in the industry. The ICREX exhibition is now growing from HVAC&R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRAE to catalyze the transformation of the budding engineering professionals. ISHRAE provides a platform to potential employers to select student members for careers in HVAC&R industry at the ISHRAE Job Junction. Young minds are made aware of the need for saving power, clean air, and sustainability. The K-12 initiative of ISHRAE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVAC&R and building services industry with just a few clicks. ISHRAE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, and energy efficiency and conservation to enter and explore the universe of the Indian HVAC&R industry. Log on to ISHRAE.in that unfolds a panorama of information Let us engineer a sustainable future together through ISHRAE.
Our world is changing. Cities are growing, food is moving faster, further, and we want healthier, more comfortable lives. These changes are driving up the demand for energy. So who's enabling more energy-efficient homes, cities, and industries? Armacell. We understand the world's energy demands and engineer solutions that make a difference. Solutions that help save energy, lower costs, and reduce emissions. As a global leader in equipment insulation, we are tackling the energy challenge, since the smallest things have the biggest impact. We manufacture equipment insulation, engineered foams and aerogel blankets, helping homes to optimize energy efficiency in solar applications, skyscrapers to reduce energy losses in air conditioning and water piping, trains to provide fire-safe insulation, onshore pipelines to prevent corrosion under insulation, and wind turbines to make renewable energy production possible. We invest in new technologies, focus on superior product performance, and constantly innovate thinner, lighter and more environmentally friendly products, so we can help cities meet the needs of energy distribution and enhance living comfort through thermal and acoustic insulation. Our vision is shared by 3,000 employees around the world who make Armacell a trusted and reliable partner and support our customers in more than 100 countries, where every individual has a passion to make a difference in our mission to enable a more energy-efficient world. Discover how at armacell.com.
Thank you and good afternoon, everybody. And thank you for all the panelists joining, speaker for the day, and all the participants. Of course, as we know that today we'll cover the topic IoT-based BMS for energy efficiency in hotels. And for this, today we have two legend person with us, and all we have a great opportunity to learn from them. Of course, this program is organized by Delhi chapter of ISHRAE, and today is one of the special day, that is Earth Day, and Delhi chapter is celebrating Earth Week, and most of the programs is being conducted under the program segment. Of course, we are doing the plantation drive as well today, and this is one of the uh, part of the Earth Week program. And Earth Day today we are celebrating with this program as well with plantation drive also. So with this, we are thankful to our partners also supporting Delhi chapters program and all activities. Platinum partner Armacell, Gold partner LP Aeroflex, Silver partner Briar DRI System Advanced Valve, and Annual partner uh, Standard Refrigeration and Paramount Quality. Before going further, I will take few seconds to share our gold partner LP Aeroflex. Four slides are there, so I would like to share. Then I will further hand over to Siddiqui sir to for the speaker introductions and proceed the program further. Hello,
Yeah,
sir.
can you hear me? Can you hear
Yeah,
us?
yeah, I can. So I was on mute. I mean, it was okay. I'm repeating. I think ALP Aeroflex word shown by me. That was my voice was clear or not, sir?
The voice was not coming.
Okay, not an issue. I will make it again. Sorry. So ALP Aeroflex is basically supporting us in all the activities as a gold partner, DCI programs and all activities. So I'm going to display over few slides, 4 slides of LP Aeroflex. LP Aeroflex is basically into the insulation solution, founded in 1985. You can see the turnover and all this little bit portfolio over there displaying here. They have global reach, India and outside the India as well. Uh, you can read out. I'm not going to read because of the time constraint about the LP Aeroflex. Key projects that they have done in airports, hospital, IT sector, industries, government, educational institutes, and prestigious international projects they have done. In India and outside the India also many key certifications are displaying over there. Uh, they have the base product line of LP Aeroflex that are Aeroflex, Aerocells, Aflex Eco. So basically they are into the insulations and numbers is displaying over there in this slide. You can take down the number, you can take it as a screenshot or you can note down the number for any queries related to the insulation and all you can contact directly. So further come to the main agenda for the day. I further request Siddiqui sir to proceed from here with the. We have two legend speakers for the day, Amarjit sir and Goel sir. So I request you to please introduce, even though they are well known to everybody, but due to protocol, we'll have to introduce them. So hand over to you, sir. Thank you.
Thank you, Mr. Tapas. So participants today for this workshop. This is the first workshop of this chapter year 2022-23, and this is being organized by Delhi chapter of ISHRAE. And luckily today is a Earth Day also. So this has been aligned for the celebrations of the Earth Day, and Earth Day is celebrated annually every year, as we know. This is celebrated worldwide today every year to remind us how we can protect the environment and how we can restore the damaged ecosystem, and how we can live a more sustainable life. So our ecosystem is very important, our earth, our air, our water, our soil. So protecting this, we celebrate today. So today's workshop is very important in the sense what all we can do for our to save our earth, and how we can cut down on the carbon footprint. So for today's workshop, we have two very eminent speakers with us. And this workshop is the topic of this workshop is IoT based BMS for energy efficiency in hotels. So basically, we are talking about energy efficiency in hotels and how we can use the system more advanced, how we can control through BMS to save energy and manpower. So today's I will not take much time, and I'd like to introduce our two eminent speakers today. One is Mr. Amarjit Singh. So Mr. Amarjit Singh is a co-founder and CTO of Zenetics Solutions Private Limited. Mr. Amarjit is an expert in embedded systems, data acquisition, and algorithms and energy efficiency. He has been a professor in IIT Delhi also. He did his BTech from IIT Delhi, then he did his MS and PhD from University of California, Los Angeles. So on this subject, he is a very knowledgeable person who can address us on the BMS application to enhance the efficiency of our HVAC systems in hotels. And another eminent speaker today with us is Mr. Prabhat Goel. He is an independent consultant and he's in HVAC energy and controls. He's a very eminent person, and he's been here in this industry, in the HVAC industry, for 40 plus years. He's an experience in HVAC industry, including design, project execution, and commissioning of HVAC systems. He's been associated with HVAC and control systems. He has done his BTech honors from IIT Kharagpur, and then CCN 1 and 2 from Carrier Bynum Institute, USA. He is visiting faculty at ISHRAE Institute of Excellence, Delhi. So here we have two eminent speakers and a very great topic for the technical workshop of today, IoT based BMS for energy efficiency in hotels. So I'll not take much time, and I'll hand over the uh, for further proceeding to Mr. Amarjit Singh. Mr. Singh, please.
Thank you, Mr. Siddiqui, and thank you, Delhi chapter for ISHRAE for giving us an opportunity to speak on this very important day today. And we feel really privileged to have a slot with uh, Delhi chapter of ISHRAE and talk about energy efficiency, especially using the new age IoT technologies, sort of challenging the way the automation has been done in the built environment using the traditional building automation and building management. So just a higher level outline, we'll talk about what does this IoT enabled energy efficiency means. We'll go a bit deeper into what is an IoT based BMS, how is it different from a traditional building management system. Then we'll dive straight. I mean, we have done few webinars in the past, and Delhi chapter of ISHRAE have themselves organized a few technical webinars. And always this request has come in that people want to hear about the real case studies. So that is where our primary focus will be. That we'll pick up one real case study of a hotel where this energy efficiency using IoT has been delivered. We'll talk about the specific values that have been delivered over there, and then we'll talk about that if a similar project has to be executed either by the end customer themselves or through system integrators, then how can one go through this incremental journey? We'll try to wrap up the whole thing within an hour or so, or an hour, 15 minutes, and leave a whole lot of time for Q&A because we want this to be more an interactive session where we would like to have people ask us questions and that may or may not have been covered, different aspects that may or may not have been covered in our slides today. So jumping straight into it, and I'll just set the context for this slide, and Mr. P.K. Goel is more an expert because he has spent almost 4 decades in the BMS industry. So what happens is, I mean, hotels are just one aspect of large buildings. It could be an office building, it could be a hospital, etc. Typically, how do you waste energy? Either your assets are inefficient, they are old, they are not operating properly, or your assets are being operated with the wrong set points, right? And nobody sort of take a deeper dive into those set points. Typically manually managed, lack of clear visibility. And how do you then eventually get energy saving? One, you do very detailed monitoring through different sensors, get the data, pass on that data to automated algorithms which are based on AI and ML that create then automated tickets which can then be rectified, and those rectification of tickets lead to, let's say, 3 to 5% of energy savings. You can then get an additional stage saving of 8 to 12% by doing automated controls. And these controls could be largely on the HVAC side because HVAC consumes about 40 to 60% of the energy consumption in the buildings. Within HVAC, it could be on the low side, high side, and then beyond HVAC, you could control exhaust and lighting as well. Rather than being more theoretical, I'll let Mr. PK talk about his 4 decades of experience and how he has seen wastages in the buildings and how he has worked on overcoming those wastages. And then we'll go deeper into the technical aspects of it. So, Mr. Goel, over to you.
Thank you, Amarjeet. Thanks to ISHRAE chapter for inviting me on this important webinar. And going ahead, I'm very happy to see that about a large audience has joined this particular webinar on this important topic. And my experience with air conditioning, HVAC, and controls goes back almost 3 to 4 decades. 70s, 80s, we used to do our own controls in HVAC, especially in telephone exchanges, etc., doing humidity control in textile environment where the fiber would break in case we had the wrong humidity and temperature, and various other places. My first experience with direct digital control goes back as far as 1988, when one of the major air conditioning manufacturers introduced the VVT system, variable volume, variable temperature system. And as a change, we could see the set points, the duct temperature, the room temperature, and the damper position, etc., all on a DOS screen. It wasn't even the time when the Windows were invented. The Windows came in somewhat later. And once the Windows came in, the systems really got enhanced. Most people really liked seeing just the data on the screen and changing colors when they would go into alarm conditions, alarms, etc., and graphics. That was novelty, but the novelty went on only for a certain amount of time. When it came to renewing service contracts and hotels, being hotels, spending a lot of money on energy, almost 20% of what they take in the front office from their customers, they wanted to focus on energy savings. And BMS systems did have capability to somewhat look into energy and save energy. But there was a question whether historical data was easy to collect, historical data was easy to archive, whether one could draw the graphs, trends, etc. One could compare this year's figure with last year's figures. So it went more on the path of integrating other systems like diesel generators, security, cameras, etc. Went on to the BACnet program, and we spent a lot of time doing all that. And somehow the industry felt that the energy saving part was getting compromised. And the other problem that we saw was HVAC got lost somewhere in the middle of all these particular things. And not only that, basically changing the system to meet immediate needs that the hotel chief engineers wanted was an issue. You know, either systems were getting obsolete or doing changes was very difficult. There was extensive amount of wiring going on, which was required even in the new jobs today. And it was normally felt that the industry needed a change. Now, thanks to smart cities and further development in electronics, remote monitoring, industrial use of controls, etc., etc., the Internet of Things came into existence, and rightly so. And there is a need for the Internet of Things to go far beyond the BACnet. I'm to say it's not just protocol related to air conditioning, but many, many other things need to interact with each other. And then the simplification started in terms of wireless systems, wireless things coming up, which are easy to set up, easy to modify, easy to change, which hotel chief engineers want. and really go into, first of all, looking into the energy that you spend in various aspects of a hotel. Now, BMS systems, as far as hotel industry was concerned, initially was restricted to the larger hotels. It wasn't there in the smaller ones. But if you see the population of the small hotels today, and if you look at the total amount of energy that is consumed in hotels, which are anywhere between 10 to 100 rooms, it will probably outstrip the amount of total energy consumed by the large players. So how do you do that? How do you bring this technology into that particular environment? And as you saw Internet of Things and smaller players coming into this particular environment, you saw more and more of that need getting satisfied. And as you can see today, a lot of the equipment has started coming in with built-in stuff that you can see your parameters, you can monitor your parameters, you can trend your parameters on handheld devices and what have you, and that too at minimal cost. So on the one end, the cost, the equipment is coming with built-in Internet of Things or other protocol communication and control coming at almost next to zero cost. And devices are being more available to people like you who are listening today. So my advice as a person who has been in it for umpteen number of years is dive into it. One way or the other, get into it. There is enough stuff on YouTube, on the internet, where you can just go around having a look and see how monitoring has become so simple. And in years to come, especially for HVAC engineers, it'll almost be assumed that they know a lot about it, because a lot of you are headed in the future towards all kinds of facility management, hotels, hospitals, what have you. And this is one technology which is useful across the board when it comes to built environment. So we all know how the global warming is taking place. And if one thing that will come to save this world, I believe at this age and time, a good part of it is going to be technology going forward and things like Internet of Things. The ease of installation is there. The ease of changing things around is there. It is more cost effective. And in the last 3 years, I've been very, very excited with the way this whole industry has changed to meet customer needs. It is no longer a heavy investment upfront and then struggling with renewal of service contracts and what have you. It has more become that you go ahead and install what you can benefit from, get the benefit, and get further. I think it's a good model, and I wish it all my best. And I will now hand it back to Amarjeet to take you through the slides and the nitty-gritty of it. So thank you very much. I will be there during the question answer session. We are in between to hold hands with Amarjeet. And feel free to ask any questions, because it is only through questions that we can get to the bottom of it and get you guys really started on this nice journey. So over to you, Amarjeet.
Thank you, sir. I think you very nicely summed up all your 40 years of experience into a few key points, right? That uh, connectivity is the future, right? All of us here, as we move into the future, whether as system integrators or HVAC engineers, etc., connectivity is going to be there in one form or the other, whether it is OEMs themselves providing connected equipment, or very easy to deploy, low cost wireless devices that can, in a plug and play fashion, provide data in a very easy manner, as you mentioned. So as this connectivity becomes a reality, which it already is there, uh, we can see that how we can create a meaningful impact on global warming. I mean, I think this year is a real wake up call. The temperatures in April have been what we have never seen in last 60, 70 years, right? Many of us were not even born in those durations, right? I think, I mean, it's nature is giving us that wake up call that we better uh, put our act together, right, and do our bit, or else we will. I mean, the coming generations will suffer, and I mean, many of us who have kids really are concerned about that coming generation, right? Um, uh, I mean, buildings consume about 40% of the global energy, and within buildings, HVAC consumes roughly about 60% of the global energy, right? So overall, HVAC consumes roughly about 25 odd percent of global energy. And if we can save, let's say 10-20% of that HVAC energy by doing the right things, we are talking about 2.5 to 5% impact at the global scale, right? Especially with, again, this Russia-Ukraine conflict happening, etc., etc., right? I mean, there are these global political, environmental impacts that are pushing us to put our act together. Technology is evolving very fast, as you have already mentioned. There are business models that are now evolving. There is no very little or almost no upfront investment. You reap the benefits and you take it one stage at a time. And we'll be covering several aspects of it, but I think you really summed up all of these things very nicely through your experience. And let's just take the audience through some of these aspects in more detail through our slides. So, where is the gap in the building management system, right? And why is there a need for IoT, right? Again, I'll use some statistics, right? If we talk about buildings which are more than 100,000 or 150,000 square feet, if we, I mean, Western countries like Europe or US, 50% of the square footage of such large buildings already have automation system in one form or the other, right? The same percentage when it comes to India is very low. I mean, roughly about 5 odd percent. And many of us know the reasons, right? I mean, many of us have seen several of these automation projects fail. So of course, India and developing economies have a huge opportunity even for large buildings. But as Mr. Goel mentioned in the earlier slides, when it comes to smaller buildings, less than 100,000 square feet, right? Globally, it's actually a very big gap, right? Less than 2% of the buildings, even in the Western developed economies, have automation systems, because these systems, the way these systems are built, they are very expensive, wired. If a building already exists, it's operational, it's very difficult to deploy it, very high upfront capex. So people can't justify the ROI, very little centralized visibility, right? I mean, and the cloud is changing all of that. Very difficult to maintain. The technologies were built in different contexts. Several protocols over time, like LAN, etc., have been outdated, but some of the equipment still come with those interfaces. So how do you uh, keep up with the older versus the newer technologies? And by the way, all of these systems do collect a whole lot of data, but don't put that data to good use. The best use that data is put for is generating some alarms, and then you are flooded with hundreds of those alarms that you start then ignoring those alarms. Right? So I think many of us who have experienced this BMS as an customer themselves or deployed it. I think you guys know many of these challenges more than me. Sir, based on your experience of deploying BMS, do you want to touch upon any other aspect or go deeper into any aspect that I may have just briefly touched upon?
So what I would say is that there is a lot of newness, and there's a lot of research, and all the research that is happening today is happening around the new platform. You know, going wireless and eliminating the in-between controller and being able to move things from one place to the other and rearrange. The churn is so much over there. So most of the attendees who are young will see the new stuff coming in rather than going back to the old stuff. So what they see coming in is of importance to them because they should be already on it. And I truly believe that this time, India should not be just buying and using things from the West, out of Western technology. India should be a part of the technology. We should be a part of coming out with sensors, with controllers, with software, which the Western world would love to deploy in its place. And look at the IT thing. Today, we are one of the major IT players in the world. And this is another technology which will give our youngsters a chance to participate globally. Okay, and I'm
That's
very,
a
very
very good
upbeat on
point.
that.
Yeah, that's a very good point. I mean, I also very strongly feel that building automation actually is similar to the mobile phone or opportunity in India, right? That India could never take the wired landlines to all the people as compared to Western world. But then India leapfrog, right? Today, the internet cost is perhaps one of the lowest in India, right? Today, you can pay a vegetable vendor digitally via UPI. Nowhere else in the world, even in the US or the Europe, you can do small payments, even few cents of payment, few rupees can be transferred digitally, and a vegetable vendor happily accepts it, right? I
Yeah,
think that is where the world of automation, especially the built automation with IoT, is moving in. It's a paradigm shift that is going to happen in the next 3 to 5 years, and definitely India has that opportunity to be the global player, creating these new tools and technologies, not just for the local consumption, but actually exporting them and
yeah.
exporting this knowledge created locally, made in
And
India, built for the world.
another thing, Amarjeet, don't forget our own tier 2, tier 3 cities. I want to say the Merats and the Modi Nagars and the Dehraduns may already have it, but you know, the smaller cities, I mean to say, if we look at the penetration of BMS into our tier 2, that itself is very small, and tier 3 is almost zero. But with the newer stuff which is coming in, believe me, in 2 years' time, you will see a small vendor in a small town even having connected systems.
Right.
He already has the internet thanks to the payment facilities. You know, he cannot have a UPI without having a net connection. He doesn't depend only on the telephone line. He has a little uh, fiber connection, even in a very small place today. And it is just an extension of that. And it has to come. This is development.
Right.
You can't stop it. And it is much
Right.
better that youngsters get on this bandwagon. So I'll leave you to the presentation.
Sure. Thank you, sir. So I think I'll spend some time on this architectural slide, right? That how is this whole system architected when it comes to an IoT based BMS? So at the lowest layer, you still have these field devices, which are similar to the field devices you would get in a BMS, right? These are devices, sensors or actuators that are talking over um, analog or digital inputs and outputs, 0 to 10 volts, 4 to 20 milliamps, etc. Where things start changing is that rather than a traditional DDC, which is wired then with the backnet controller, you put in an IO card, which is then communicating wirelessly to, to an IoT gateway. In addition, you may actually have some of these equipments that already come with wireless connectivity, right? I mean, there are large OEM players, pump players, some of these valve players, actuators that are now coming with connectivity inbuilt into them.
And the chillers.
The chillers. Why add an extra piece of hardware if that connectivity, especially the wireless connectivity, is coming in? So you will see more and more of these API integrations that will happen, the soft integration without any hardware. These IO cards or the gateways will also talk to the new age equipments that come with their own wireless API based interfaces, right? An interesting thing to now also look at it is that at this gateway layer, again, things are very different. Because rather than wiring all of these IO cards back within a large building or within a campus that may have multiple buildings, all the way to a central backnet controller, you may think of a large building as smaller zones. And each zone may have its own IO card, a whole bunch of IO cards, one gateway, and the gateway directly communicating to the cloud. And the notion of the building or the notion of the campus is then a soft notion, which comes by aggregating the data from these multiple zones within the building or multiple zones within the campus, each served by its own gateway. And then everything comes together as a building or a campus in this cloud entity, and not having to wire everything in this local space. Once you have all of this data, you put this data to the best possible use. You are now collecting data pretty much every minute. The storage is cheap, compute is cheap. You process this data through your AI-based algorithms, create automated tickets, right? People don't need to infer that data. Those data points are inferred by automated algorithms that keep improving themselves as and when they get more and more data, and create tickets. These tickets will have actionable insights rather than saying that there is little cooling in a specific area. The ticket may actually say that there is little cooling because the air filter is blocked, right? Or because the valve is stuck, is not operating, or because the VFD is stuck at 30 hertz, etc. Right? So because these systems are now analyzing data across multiple of these subsystems, that analysis goes into the algorithm to create actionable insights for the field technician to operate upon, rather than just simply giving a higher level diagnosis that there is low temperature or there is high CO2, etc. You do, of course, get real-time visibility of this real-time data. You get visibility in terms of tickets, but then you also can, it's a two-way communication. You can push back the controls as well. And by the way, those controls are not only managed in the cloud. At every layer of this IoT architecture, the systems are now smarter. So the local PID logic is actually running on the IO card itself at the lowest possible layer, which means that even if the IO card gets disconnected from the gateway, it will keep doing its own operation. There is another level of edge intelligence that is there at the gateway level, which means that even if the gateways get disconnected from the cloud, they keep doing their intelligent operation. Right? And then, of course, cloud has a whole lot of AI and machine learning algorithms, right? So essentially, this IoT creates a distributed architecture with intelligence at every layer in this distributed architecture, ensuring that even if some subcomponents, subsystems get disconnected, they continue to operate in an intelligent manner. And ensuring that eventually whatever large volume of data that you collect is put to the effective use by creating um, actual insightful tickets, and by doing automated controls without any manual intervention, and all this while ensuring that you deploy the minimal possible hardware, right? If the systems are already connected, if the systems already come with a communication port, just interface them. Just try to do everything in a plug and play fashion, wireless first fashion, deploy minimal amount of hardware, and that is how you get the lowest cost. Replace all the intelligence in the software than trying to put in more and more hardware, which is again a very paradigm shift from how traditional automation is sold, where software pretty much comes at free. I mean, 2 to 4% of the project cost, while the hardware is the major chunk. What we are saying is, let software gain that traction, because that also opens up new business opportunities for system integrators, where it's not just a one-off project that you do the execution, you come out of the customer. No, you do the execution, you remain with the customer for the lifetime of the building, because you are now getting real-time data. You can see that data remotely, you are giving the service, you are giving the maintenance, etc. So you create your recurring model, recurring fee model, and build a long-term relationship with the customer rather than a one-time fee and one-off project-based model. Mr. Goel, you would have any comments?
Yeah, I think the last part really made sense. And Amarjeet, I'll go one line further, that the youngsters in this particular crowd who are listening one day will give the run for the money to the person, to the IoT companies. You know, they will become so proficient with the experience in these particular things that really the very low level things will not have to be done by the IoT based with the IoT companies. They will be able to handle it by their own hands, because it will be so simple that it will enable them to become more powerful. You know, they will have a better place in the hotel industry or any industry that they work in, because the power will go into their hands, rather than them having to ring up someone and ask, okay, what is this equipment doing and how is it working? They will know it on their handheld how it will be working. And if they have a problem, they will come back to the intermediate company and say, hey, how do I change this from here to here so that I become more powerful? That's the name of the game. So go ahead.
Yeah, I think that's a very good point you brought in, and we have already seen it. I was in Dubai in the month of December, and we had deployed a few of these systems on top of a BMS over there. And I was surprised. I mean, we visited one of our deployments, and the engineer that was showing us was so excited. He said that this AHU went bad, and I actually got to know from your system sitting remotely, and before the customer could got to know about it, I came here, I serviced it, or else the customer would have felt the changing in the temperature themselves, right? So there were those things when you hear back, right, from a young guy, right? I mean, in early 20s, he was so excited, and he felt so empowered that yes, you have now given me data on my phone, right? And I can proactively go and uh, uh, rectify the problems in the field, and I have better insights about how the system is operating just because I can now see the data. I think that paradigm shift is already happening in the field. So why IoT, right? Connected systems, of course. So imagine if you have multiple facilities as an SI or as an owner that may have multiple hospitals or hotels. Um, you can get centralized visibility across your sites, right? You then, I mean, we often have this conversation, and Mr. Goel brings this up many a times. Boiler room to boardroom discussions, right? IoT changes those discussions by bringing in business metrics, right? So for hotel industry, we often give them energy consumption per occupied room. The moment you start doing that, and rather than just saying that energy consumed yesterday, right? Suddenly, your boiler room discussions start becoming boardroom discussions. That, oh, my room rental that I charge as a hotel, 40% of that is going into energy consumption. Can I reduce that? Right? Because that's a significant chunk. Of course, the whole system is very, very cost effective. As I said, because it is hardware light, software rich. Do not deploy unnecessary hardware because it increases the upfront cost. It also makes the whole system complex and difficult to maintain. Which brings me to the next point. Very easy to deploy. You are not putting wires. Most of these sensors are battery powered. It's a wireless first thought process. So even in an existing building, we even say that statistically, people say that of all the buildings that would exist in 2050, right, more than 25 years from today, 50% of those are already there and built today, right? Which means if we really have to bring in energy efficiency in the built environment, we have to make sure that the whole system is retrofit ready, right? You cannot disrupt the ongoing operations of a building. And therefore, things like battery powered things, philosophies like wireless first, will drive that adoption in a retrofit in a brownfield environment. Unlike in an BMS industry, which is typically catering towards the greenfield projects. And then it's conditioning, monitoring, driven maintenance, right? I mean, we have been now working with several of the even data center players, right? Where typically they would send a staff every 2 months, every 1.5 months to do some specific monitoring of their equipments in the field. Are the UPS working properly? Do some of the batteries need maintenance or replacement, right? Now, rather than doing it at a specific time frequency, because you are getting the data, you are doing analysis on that data, you can do condition-based maintenance rather than doing time-based maintenance. Right? So, and many, many more such benefits. So with IoT, you can do a lot more than a BMS at less than perhaps half of the cost. I think this is a bit technical, but we still added it because I think it's useful to go a little bit deeper that how exactly is BMS and IoT different, right? What we tried to do here was to put in different layers of data and control that exist within the BMS, right? So start with ambient sensing. Today in a BMS, you take the return air temperature at the AHU level and then you control, right? BMS has no clue about what exactly is the temperature in the actual occupied area, unless there is again a thermostat in that area that is controlling a VAB, right? But in our case, maybe if there is no such thermostat, then BMS doesn't have that visibility. What you can do is, even in an existing BMS, just plug in these battery powered wireless sensors. You don't need to power them, put multiple of them in your occupied areas, and suddenly you can get the comfort level of occupants in the building. And occupants are typically not even thought of as users in a building automation system, right? While they are the ones who are eventually getting impacted by if the systems are not performing well. Then you go to the low side control. I already talked about that in my system architecture, that you will typically have your DDCs that are wired either in the low side control or the pumping equipment and to the backnet controller. And these DDCs are now being replaced in an IoT ecosystem with a wireless IO card, keeping the same edge devices, right? So not really saying that, okay, if you actually have an existing BMS and your edge devices exist already, right? Just simply take them out from the DDC, plug it into a wireless IO card, and you will still work. You don't need to replace an existing system, right? So you can, if you have an existing system that is not operational, an IoT can come in and sort of try to reuse some of the components of that ecosystem as well. Then you start going on the higher side in the chill water system. You would have a typically a chiller plant manager wired to a backnet controller. In an IoT based system, you would have direct integrations with a CPM or a wireless based CPM. Then you would have a central controller which where everything gets wired together, and that is what is talking over protocols like backnet. Versus in a BMS, you divide the in an IoT ecosystem, you would divide the building into zones, and each zone would have its own gateway that is independently publishing the data over internet, and the notion of building or the campus comes as a soft notion. BMS also collect a whole lot of data, but all the data goes into a local computer in the facility, and nobody knows whether that data is of good quality, whether that how you can use that data. In an IoT system, it's a cloud-first technology, so you don't even actually have to invest into that IT infrastructure. The data goes into the cloud. You in fact start collecting data at a much higher resolution. We in our systems collect data every minute, pretty much from all our systems, and then you put algorithms to work. Today we get 200 million data points across our deployments every day, and it's not manually possible to look at those data points to make manual inference. So you rather put automated algorithms, work on those 200 millions and billions of data points, right? Which sort of takes me to the topmost layer that in a BMS, typically you would have a human doing the set points and alarm management, while in an IoT system, it's the algorithms that are doing the adaptive and the intelligent control, right? Mr. Goyal, it's a bit technical, but I mean, I know you love going deeper. And would you like to bring in your experience into these different layers, and perhaps even some of the challenges from the execution perspective that some of these building things don't pass on from generations across people, etc. Some of those challenges as well.
So all I would sum up is in one word, which is adaptability. You know, previously we did not have adaptability. If you did not look at the filter dirty sensor for 1 year, you did not say that, you know, how do I make use of this sensor by moving it to some other place? Whereas in an IoT system, if you have not looked at a sensor for 6 months, or it has not contributed to you, think of ways by which you can redeploy it. Okay. The other thing is, suddenly in a 10-storied building, you are getting complaints from one floor, and somebody is saying high temperature, somebody is saying low temperature. With the BMS, what will you do with it? You know, you have to go with a stick and open more dampers, close more dampers. Now you can go plug 15 wireless sensors on that particular floor for the next 7 days. And you can trend them, and you can see who feels comfortable at what temperature. You know, those kind of possibilities are much more there. So all I would say is one word: the adaptability it brings into the system, which during Q&A, I would love people to challenge this concept that adaptability has increased, or has it remained at the same level? You know, when things become so obsolete so fast in these systems, that we HVAC people, we've seen the same compressor for 20 years. Over here, you go to with one controller or one particular thing, and he says, "Ye to 10 saal pehle chala gaya." You know, change the whole thing. We are not there to change the whole thing. You should be able to change bits and pieces. There should be interoperability, which IoT brings in a very good manner. I think you'll talk about that. So these are other things that will come into play. I'll leave it to you now.
Yeah, I'll jump into the case study. My assumption is that this will perhaps be one of the most exciting parts, because it's a real example of how whatever we have been talking about so far has actually delivered energy saving to a real customer. So who is this customer, right? It's one of the largest airline catering companies in India, operational in multiple cities, 24 by 7 operational facilities, right? With over 110,000 square feet area and average monthly energy consumption of about 42 lakh rupees, right? What does their infrastructure looks like? About 20, I mean, and this we are talking about one of their buildings, 20 cold rooms, uh, 5 deep freezers, 2 diesel generators, 2 UPS systems, 3 blast chillers, 1 main incomer, 4 floors, and within an HVAC system, 25 AHUs, 4 chillers, 1 TFA, 21 fresh airs, and 21 exhaust fans, right? So that sort of gives you a picture of the type of facility we are talking about. And what did we do? Uh, so we first went into electrical monitoring, right? We put in a whole bunch of energy meters at different levels. At the mains level, we did real-time power consumption, we did fault detection, we did power factor, current imbalance, voltage monitoring, and the benefits were sort of they looked into the billing inconsistencies. Right? They could now match what the bills they are getting and what the meter is saying and compare the two, right? Uh, in India, several utilities give you penalties if there is low power factor compliance. So rather than being reactive and looking in their bill that, oh, in the last month they didn't maintain a good power factor, they now get a real-time alert and ensure that they avoid those billing penalties due to low power factor compliance. And then, of course, things around electrical safety, right? There are a whole bunch of three-phase equipment where perhaps the winding is not working properly, and that would lead to different current imbalances across different phases. Or maybe you have a few whole bunch of single phase equipment, but they are not distributed in the right way. So if you have current imbalance, voltage imbalance, if your voltages are not being maintained in the right range, you can have safety issues, right? And those issues are then brought up then and there in real time rather than being reactive. Then we put in energy consumption monitoring at the chiller level. Because we are collecting data at a very fine resolution, sometimes even lower than every minute. We were able to do health monitoring, right? We optimized on the set points. We computed the IKW per tonnage for tracking the efficiency. We did the health tracking and we were able to check on the run status of the chiller. The building also had solar, so we did the solar plant monitoring, we did the DG monitoring, and we could again do health of these assets. Is your solar producing enough power given the weather conditions today? We were tracking that, we were raising alerts. We were telling them if there is potentially a DG fuel pilferage because whatever fuel they filled in, did they get enough units of consumption out of that or not? How many run hours DG operated at? Was DG operating at the right capacity? You may have a over provisioned DG or an under provisioned DG, etc. All of those things can now be provided from the data. We went further deeper into electrical monitoring at the low side of HVAC as well. So we did AHU monitoring, exhaust monitoring, TFA monitoring, pumps monitoring, and then within refrigeration units, we did phase-wise cold rooms and deep freezer monitoring, blast chillers, and essentially again it gave us health of the equipment as well as because we were talking about this being a catering company. It's also about food safety compliance, right? That if there are certain perishable products, are they being stored and at the right temperatures or not? Is also very, very important for them. Then we went to temperature monitoring. Within HVAC, we did temperature monitoring in case there is a breach of temperature, generated alerts. We looked at whether occupants are having the right comfort factors or not. And as I already talked about, within refrigeration units, Are they maintaining the right temperatures, especially for the perishable products? If not, is it because the equipment is not healthy, or is it because the set points of the equipment are not being maintained properly? All those actionable insights are then given rather than simply saying that you are not maintaining the right temperature. Right? We went beyond monitoring, right? So beyond energy and temperature monitoring, we got into the control as well. We did the direct control of AHUs, exhaust, DFAs, FAs, pumps. We control several of them via VFDs, AHUs, exhaust, CT fans, and FA units. And then so direct control is the on-off control. Then we did some of those equipments control via VFDs. We did the modulation of the valves through our wireless IO cards. And of course, I mean, I think now they got deeper insights into if any of their valves was stuck, or if the supply temp, I mean, if there is not an optimum supply of chilled water, resulting in energy wastages or temperature not being maintained properly. So this was the real proof, right? We looked at the consumption for about 5 months before the system was installed, and we looked at the consumption for the 5 months after the system and the whole automation was put in place. And we showed real 14% savings on actual energy bills. So it's not just that we were showing savings, but their bills were similar. The bills actually showed savings as well. And the overall ROI was less than a year for them. Right? So these are kind of the ROI numbers potentially unheard of. And in the BMS, you don't even talk about ROIs in terms of energy savings. Here, we are saying that you do savings and you do get an ROI. So that is of course in terms of real money that you get an ROI of. But beyond that, there is of course better temperature compliance, right? So what does a temperature compliance mean? So for example, um, let's say if a cold storage is the ideal temperature for a cold storage is 2 to 5 degrees Celsius, right? Now, if that ideal temperature is maintained for 16 hours in a day out of 24 hours, then the overall temperature compliance will be 16 divided by 24, which is 67%. So the customer gave us these compliance ranges. The cold storage should be between 2 to 5. There was another cold storage which should be maintained between -20 and -18, and a deep freezer which should be again maintained between -20 and -18. What we could show them was this. These are on the x-axis, you see different equipments, and on the y-axis, you see the temperature compliance, right? It's a box plot where this middle line shows the median value. The box shows the 90 percentile, and then the rest of the dots are outside of those 90 percentile. Right? So here you can easily see, and we mark it on what is an ideal temperature compliance and what is a low temperature compliance. So these equipments, even to E9, are largely operating in a low temperature compliance mode, either too cold or too hot. And then we look further into their energy consumption to create automated tickets with deeper insights about why they are showing low compliance. And the rest of the equipments, E10 through E21, especially these equipments towards this side, E17 to E21, have very good compliance. Right? So they're getting this real-time visibility, and any equipment any day can go from a high compliance to low compliance if there is a fault in the equipment, or if, let's say, somebody has manually put in a wrong set point. And once they do those corrections, either the equipment is maintained, either a servicing is done or the set point is changed, and equipment can move from low maintenance, low temperature compliance to then a high temperature compliance. We got into the asset health as well, and I'll give you one example of asset health, right? So here we are showing the current consumption in the cold storages, right? If you look at the green graph, this cold storage is actually giving a duty cycle of its compressor. The compressor is going on and off, right, in a nice periodic fashion. While if you look at another cold storage, which is depicted by this yellow line, this is being on for most of the time and is being off very little, right? So what we do is we look at the duty cycling, right? This duty cycling should not be very low, because very low duty cycling either means that you have put in a very low set temperature, which is not being able, which the compressor cannot achieve, and therefore compressor is always on, or perhaps the compressor has some fault, like maybe there is a gas leakage, etc. And therefore the compressor is not able to cope up with even the nominal set point, right? So very low duty cycle is bad. Very high duty cycling is also bad, because that can then make the compressor go bad because you are unnecessarily switching on and off. So therefore your duty cycling should be in an optimal range, and our algorithms calculate this optimal duty cycling, and then we show that. So these are again some equipment cold storages, CS1 to CS8. For each of these cold storages, we have an ideal duty cycling range, and then there is a high and there is a low duty cycling range. So you can see CS3 through CS7, their median values are in this ideal range. CS3 is barely in that ideal range, while CS1 and 2 have very low duty cycling, and therefore is resulting in both energy wastage as well as perhaps the equipment health is not bad, is not good. And CS8 is showing very high duty cycling, and that again may lead to potentially a lot of uh, uh, may lead to eventually the equipment getting conked off, right? So these are the examples of how we get into the asset health monitoring. Eventually, based on all this energy savings, temperature compliance, asset monitoring, what are the real values that are being delivered, right? I talked about electrical and compliance monitoring, right? They can compare their energy consumption with the bills, look at the power factor, voltage and current imbalances, and sort of make sure that the electrical safety is being taken care of in a real-time manner. The solar and DG is being monitored because these are the assets where you have put in a huge upfront investment, and you want to ensure that you are using them in a right optimal manner. The solars are getting clean, DGs of right capacity, there is no fuel pilferage, etc. The temperature, humidity, and AQI levels are being maintained, and you get the real-time visibility on a dashboard like this, of how your facility is being maintained, right? And this is both a web dashboard, and you can get a mobile version of the same as well. Then you start monitoring and automating controls of your assets, right? So these controls are now in your hands over the web. You can do time-based scheduling or automation of these assets. You can do action-based controlling as well. You may say that, look, at the sunrise time, I want to control this. At the sunset time, I want to control this. When the temperature reaches this value, control this. When the temperature reaches a certain another value, perform another control action. All of those control rules can be supplied through a web-based interface. um, get a real-time visibility into your food safety compliance. And being a catering company, they're very, very serious about it. You eventually save money, and that money is not even being accounted for because we don't have that visibility, that how much of food wastage has been reduced. And that's an added icing on the cake beyond whatever are the real energy savings that we give them. Guest comfort, right? I mean, you now start bringing in the real occupant in the whole scheme of things for the automation, right? You can really ensure that eventual guest in the facility who is actually paying for it is actually getting the right comfort level, right? And then of course the predictive maintenance, right? There are these complex algorithms that run in the cloud that identify these anomalies, create automated tickets with a lot of actionable insights embedded into them. And then if the data is showing that the anomaly has been taken care of, automatically close the tickets. Right? So it's a full ticketing system with automated opening and automated closure of the tickets. Um, Sort of essentially saying that, okay, I'm not increasing the work of the facility manager, right? I'm putting in systems that are throwing in millions of data points, but I'm not then expecting you to analyze those data points. Of course, um, many of the facility managers we work with, they have a whole lot of insights that we learn from, right? And we usually use those insights, embed those insights into our algorithms, so that even we learn whatever we learn from each of those facility managers, we can translate that into algorithms and then pass on those learnings to other people as well. So in a way, our algorithms act and as we keep talking to more and more facility managers, we keep fine tuning them. So our algorithms serve as a shared resource of information or knowledge that we gain from different facility managers, and we keep improving those algorithms with time. So with this case study, let's say if you as an end user or you as a system integrator seem very interested in taking IoT to your building, right? Or a building for your end customer. How can you do that, right? We propose an incremental journey. So rather, I mean, typical building automation projects in the BMS world are one time, do everything together because you have to wire everything. We change that philosophy. We do a paradigm shift. We say that take things slowly and reap benefits from it. In the first stage, maybe just do basic sensing. Put in some energy meters, put in some ambient sensors. If there is already a BMS, integrate that. If there is no BMS, adopt a wireless first approach, automate your existing brownfield building. Bring the data to a central place where our algorithms then work on that data to create, uh, first give you a centralized dashboard, centralized visibility, then perform automated anomaly detection to create tickets which are being sent to your on-ground staff. Your central engineer may have a real-time visibility into how those tickets are being addressed, and then eventually leading to improved compliance. Very low cost project, only basic monitoring, no control, but sort of will again give you a very high benefit. So very quick ROI, less than a year, right? So let's say if your whole BMS for a project would cost 100 rupees, stage one for an IoT based thing would perhaps cost anywhere from 5 to 10 rupees. Put in a very small investment, reap the benefits of those investments, see for yourself the benefits, see for yourself the ROI, and then move on to stage two. I mean, of course, this stage one will give you web-based dashboards that I have talked about all of these benefits around safety, etc. Right? Stage two, go into the automation. Right? Start going into the automation. This automation could perhaps first be done on the low side because it's much simpler on your FAs, TFAs, exhaust, FCUs, CSUs. Do it time based, do it sensor based. You can even do it on your smaller HVAC units like VRVs, VRFs, and ducted splits, right? Because you are now doing automated control, you're doing the set points in an automated manner, you start saving more and more energy. So going back to my cost example, you have spent 5 to 10 rupees doing the stage one, reaping its benefits, spend another 20 odd rupees, 20, 25 rupees in stage two, and reap its benefits again with an ROI of less than a year, because now you are getting more savings because of the automated controls being put in, right? Once you are past this stage two, you can actually be in a place where you can connect an entire portfolio onto a common platform. This common platform could be for a customer who may have multiple properties, or for an SI who may actually have multiple customers, each with single property as well, right? So there could be certain properties that have BMS. Simply connect with the BMS. Do not try to replace it if BMS is already operating. If the buildings have a partial BMS, integrate with the BMS for whatever it is already doing. For the rest of the part, put in that additional components of hardware, and then make sure that you have 100% coverage. And for the buildings that don't have a BMS at all, deploy a fully connected automation solution, right? Bring everything onto a common platform, make it a boardroom discussion. The owners are no more now the facility guys. The owners can be corporate business owners, corporate project leaders, regional project managers, beyond, of course, the site chief engineer, right? So suddenly you start with all this data, automated control, the whole talk about ROI, the whole talk about energy savings, the whole talk about guest comfort, the whole talk about condition-based maintenance, etc. Suddenly makes all of this from boiler room discussions to the boardroom discussions, right? Perhaps move on to stage 3, do more advanced automation, right? Move on to the high side. You can try to do a whole lot of chiller-based or chiller heat load optimizations, etc. That can give you additional energy savings. And then, I mean, if you are very, very progressive, move on to stage 4. I mean, beyond the HVAC, start integrating other systems. Buildings have access control systems. Buildings have CAFM. Buildings have occupancy systems. Buildings have fire alarm systems, right? And all of these systems may be sitting in their own silos, but IoT can allow bringing in all of these systems into a common platform. With now you have centralized visibility. Your algorithms can now be better because you are now getting occupancy data, or from your access control system or your occupancy detection system. You can actually have not just the presence or no presence, you can even know how many people are present if you start doing algorithms on the videos that are coming in from your surveillance system, right? So your overall HVAC optimization can have better control policies the moment you start integrating these systems. Beyond, of course, the benefit of bringing all of these systems into a common platform, right? I'll stop here. As we promised in the beginning, we want to make this whole thing a very, very interactive thing. We would like to dive into the QA session, but before going there, Mr. Goel, if you have few final comments to make, and then we can move on to the Q&A.
Okay, so couple of things, which came out during your talk also is that you can be at level 5 or you can be at level 75 and you're trying to reach 100. I'm to say, don't be afraid. Start somewhere. If you have a useful life left of 30 years in air conditioning, your only chance to succeed is if you get onto these particular technologies. You can't just live doing compressor and psychrometrics and cooling tower and other things. At some point of the time or the other, you will have to know something about the IoT getting integrated into your HVAC system. If you are an advanced player, you are at 75, 80, 85. Research much more as to what is happening today. And like you said, if you already have a working system, then get on with the gateways and see how you can get it onto your other platforms. But if you are at level 5 or 10 and you need to start new, start with the first controller. So there is something for everyone. One of the questions that I had on the net was, in the meantime, on the chat was, can the existing VAV systems be integrated onto IoT? So if you are already on BACnet in that VAV system, maybe you will be able to translate that BACnet data into to MQQT and take it to the net and benefit from that. But if you have a very old system and it doesn't communicate anywhere, you might be able to retain the actuator at the end of the day. So always talk about retaining what you can retain, and then start small and grow big. The second question which has come in
So, sir,
is,
before you go into the second question, I'll just add on to it. So,
yeah,
I think of it this way that, uh, and you have actually told it in your detailed answer to that question as well, that you would have, let's say, your actuator may already be taking commands over 0 to 10 volts or 4 to 20 milliamps,
correct.
and you may already have a temperature sensor, or if not, what you do is you simply bring in a wireless IO card, connect the analog output point to the existing actuator, either use the existing temperature sensor or put in a very low cost NTC on
Yeah,
that wireless IO card,
yeah,
program, and you can program that wireless IO card from the cloud. You don't even need to program it locally.
correct.
Configure that, I mean, I would not even call it program. Configure that IO card from the cloud to
Yeah,
set up a closed loop control between the temperature input and the valve actuator. And then, bingo, you actually can now set the temperature, change the set temperature, do the valve control, even if you don't have a BMS connected system in a fully retrofit brownfield environment with a wireless first ideology.
yeah. So the second question that has come in is again on security. You and I haven't addressed security today. And obviously, I think you should speak something about security before we go into Q&A.
Yes, yes. So I think, I mean, we should have perhaps included a slide on security. You are right that we missed on that. I think security is definitely a concern, and there are different aspects of security. I think one aspect is brought in by Mr. Jose,
Yes,
and that's one aspect that, look, IT guys and facility guys are two different teams, right? Now, if facility guys want to bring in this IoT based system, IoT guys will have their own rules, right? That they may have their certain hindrances, right? So we try to uh, work together with both of them in multiple ways. One possibility is that we work together with the IT team and we ask them to create a separate virtual LAN for us. That virtual LAN is completely isolated from their regular LAN. It is very easy for any IT team to set up a virtual LAN, and then this virtual LAN is meant only for authenticated devices with specific MAC addresses, and therefore the whole security and this virtual LAN is completely isolated from their primary LAN, and therefore the security at the IT level is typically taken care of. The other way we try to address this aspect is where we say that, look, we will bring in our wireless sensors that are talking over a wireless mesh, and that is not Wi-Fi. We
thread.
create our own parallel wireless mesh similar to Wi-Fi, and it's a very low cost, very effective mesh, which is meant for a small building. We create our parallel mesh, which has nothing to do with IT department, that over this mesh, my wireless sensors and my wireless actuators talk to the gateway. Gateway is communicating to the cloud over the cellular network. So therefore, we actually do not get into the IT network at all, and
At all.
therefore their security is being taken care of. Now, talking about security within our system, right? Of course, that is being handled in multiple ways. The whole data communication between the sensors and the gateway and the cloud is fully encrypted. We do, and I mean, it's the same AES encryption that your bank accounts use today. Uh, we add another layer of data security by transferring this encrypted data over a virtual VPN, right? That's another layer that today, for example, IT companies do for their laptops, right? So if you as an IT professional are working for an IT company, you, beyond using a secure internet, you actually use a VPN to log on into your company's network, right? And then of course uh, there are right authentication mechanisms, etc., right? Beyond that, what we also advise customers and we also take care of ourselves is that there are certain things which are mission critical, right? for example, your lift operations, etc. Do
Yes.
not let them be
No.
controlled by the
Yes.
cloud, and let that
Absolutely.
control be the local control logic, so that
Correct.
even if there is any security hazard, those critical operations do not get impacted because of
Correct.
them being cloud controlled, right?
Correct.
Mr. Goel, if you want to add any other thing, please.
So, I study at all levels, and I would go down to a very, very juvenile young people level and say that if you're so bothered about security, go and look what Apple is doing. Over there, the home system doesn't even go to a cloud because you keep everything within your network itself. That is a very juvenile way of doing things, but even that is possible. So some people, especially airports and other people in India, they will come with this particular thing that we don't want our data to go out at all on the cloud. And the answer to that will be basically installing the server in their premises itself. And then how to update the software and all will be an issue. But that is at both ends. Very small, one office wants to do it, doesn't want data to go out, or very large, like an airport, which doesn't want data to go out. Okay. So that is one part. Second is, I saw a very good observation coming from Mr. Puri, who talked about what about the IO modules and software, any recommendations on training. I think in time to come, people like you and me will have to set up some training on IO modules for people who are interested. I remember my days in 1980s when I unboxed the first IO module as a mechanical engineer, held it in hand, interfaced it with RS-485 and 232, and programmed my first temperature sensor, or my first 0 to 20, or my first uh, uh, relay actuator. It's very exciting for young people to do that. And one way or the other, we should be able to help them with ISHRAE Institute of Excellence coming in between if possible. ISHRAE Institute of Excellence has got some space with them. I tried once to put an IO controller over there, didn't get too much help from other people. But I think now with people getting interested, we should restart that activity. So over to you, Amarjit.
Yeah, no, I mean, you and I have talked about it, and you have a very personal interest. And I mean, I come from the academic background. We would love, we are already in discussions, and we are thinking of setting up a course around this IoT based BMS. Um, so, I mean, it is good to see people asking questions around it, and hopefully in the months to come, we would refine that thought process further, work together with ISHRAE, and set up that course as well. There is this question around maintenance of wireless connectivity and battery operated devices. I mean, I think so far we have deployed roughly about 50,000 plus devices of our own, sensors or actuators. Many of them are wireless in the field. I think one lesson has been that the wireless actually has evolved to be very, very rugged. And mind you, we are not talking about Wi-Fi, which is a single point that all devices are talking to the router. We use what is called as a wireless mesh, which means that the sensor will talk to the nearest routing device, and there are multiple of those routing devices. Even if one of the routing devices go down, the sensor can then communicate to another routing device in the vicinity. So the mesh is overall very, very reliable. We hardly see any data loss, any maintenance issues. When it comes to battery life, with two simple AAA batteries, no special batteries, and with 30-second sampling rate, we have done a whole lot of power optimizations that the whole system with two AAA batteries and 30-second sampling rate can last for roughly about 1.5 to 2 years. If you increase the sampling rate to, let's say, 2 minutes or 5 minutes, you are really talking about batteries lasting for 2, 5, 8, 10 years as well, right? So I mean, I think our experience has been very different, and that's actually coming from real field experience. that these wireless sensors are very easy to deploy. The mesh ensures there is enough redundancy that is being built at the time of deployment, and the battery optimizations are such that you don't need to go and replace those batteries. And even if, as and when there is a need in multiple years to replace the batteries, because these are standard AAA batteries, they can be done directly by the end customer without you having to send someone to the field to do that. There is, of course, a comment on sharing the slides, etc. I'm sure ISHRAE is doing this recording, and they typically put these video recordings on YouTube. So I'm sure everybody would have access to those video recordings in a public manner. So you can always go back and look at the whole recording.
So Amarjit, I would go on to the 135 comment or question, which has come out as an anonymous attendee, and it talks about creating multiple IPs, things like BACnet IP integration and RS-485. And one has worked on at least 2 out of the 3 platforms. The RS-485 does ring a bell, and one worked very heavily on RS-485 or DDC controllers, each with an address, and you had 64 or 128 sitting in a LAN, and then you put a 485 to 232, and you took it to the serial port, and there you were, you had all the data with you. And really, there was no need for creating anything to communicate it to the outside world. It's only when you started adding modems to it that, things started becoming transparent on that LAN also, and it became kind of a security risk. So this question seems to be with someone who has a large organization, has a well-developed IT department, and they don't want to see too many IP assignments in their building, and suddenly somebody enters from one of them gets compromised and things like that. So I think with the mesh network and with thread and other things, this is being adequately addressed, but your thoughts on it?
Yes. So I think, these are interesting points. See, RS-485, the register mapping is easily available, and therefore, typically the integrations over RS-485 are easy. When it comes to IP-based integrations, some challenges that we also see are that while BACnet is an open protocol, often some of these OEM vendors, they put their proprietary flavor on top of BACnet so that it's not easily integrated. I mean, you can't, as a third party, you can't easily integrate your systems, right? I mean, when something proprietary has been put into it, then it's the responsibility of the customer to then go to the vendor and say that, look, you have to give me a open BACnet compliant device, right? I think when it comes to IPs, etc., we solve that problem by saying that we don't need any static IP assignment, because each of our gateways actually have a VPN client running into it. And now we are adding another layer of security by doing the cellular connection over IoT SIM cards. So today, Airtel, Jio, Vodafone, these telecom operators, they give you secure SIM cards. What that secure SIM card means is you tell them that these are the 4 URLs that these SIM cards should route data to. If any traffic is coming from a 5th URL, or if anybody is even trying to go to Google, data will not go. These SIM cards themselves at their layer will stop that data. So and these SIM cards actually come with a static IP of their own, which is IPv6. So if you have an IoT SIM card, you get a static IP from the telecom operator itself at no additional cost. On top of that, we have a VPN client running in our gateways. And because by virtue of that, we get a static IP on our VPN. So really, we don't need the IT support because of multiple static IPs that large scale implementations require. We can circumvent that easily by getting into either the VPN or getting into the using these IoT SIM cards that come with this static IPv6 address. I think Mr. Goel may have lost his connectivity. You guys can hear us, right? Tapas, can you confirm? You can hear me?
Hello. Yes, sir.
Yeah. Okay. So there is another question: is there a provision of monitoring the battery life of wireless sensor? And I think that's a very good question. And I'll talk not just about the battery life, but other aspects. See, I already told you guys that we have deployed more than 50,000 of our own sensors or other control devices in the field, right? Now, when we deploy these devices, because we want to give energy savings as an output to the customer, we want to make sure that our systems are operating in a healthy manner, which means we take upon deployment as well. I mean, the maintenance as well. So what happens is from each of our sensors or control points, we are collecting a whole lot of health information. For example, from a wireless temperature sensor, we not just get the temperature value, but we get the battery status, we get the signal strength, we get how many times it has rebooted, how many times it has tried to reconnect, etc., etc. So we collect a whole lot of this health information, and as we keep deploying more and more systems, this health information then feeds into making our systems more and more robust. So when we get a whole lot of this health information, we analyze that internally, we take some corrective actions if required to make our systems more rugged, and then all of our systems support what is called as an OTA, over the air update. So whatever new ruggedness we built in based on all the health information that we collect, we modify the software, we then roll out that modified software remotely without anyone going, without having the need for anyone to go to the field. And then all our systems now have an upgraded version, which is more rugged, more secure, etc. Right? So today we have deployments across more than 200 cities in India, and we manage most of those deployments remotely. We upgrade the systems remotely. Hello.
Hello.
Yeah, I think there was some disturbance. I'm back.
Yeah.
Okay.
Yeah, so I mean, we collect a whole lot of health data. So, Mr. Goel, while you were not there, I addressed that question
Yes,
of.
I could listen in. I could listen in through my monitor. So that was another mode. That was not a panelist mode, but that was a listen in mode. So I could listen in. I do my, see, this is how you create backups. Yeah.
Right.
So calibration of sensors. There's a question on from Anil Bhatia on calibration of sensors.
Yeah, so I'll touch upon that as well. See, many of these sensors today are digital sensors that require minimal to zero calibration, right? I mean, the temperature sensors, they come factory calibrated, and I mean, they are now on a technology that doesn't require you to calibrate them every few years. So I think most, in fact, I would say pretty much all these sensors that we use require zero calibration, except for maybe, let's say, the AQI sensor that requires some amount of calibration. Part of that calibration we, to some extent, handle in the software, because what we can simply do is we can ask the customer to place, let's say, another, an equipment with which you want to do the calibration, maybe, or one of our field technicians goes there with that equipment, place it, we collect the data, we have the data from our sensor also, and then rather than doing that calibration in the sensor, we do that calibration in the software running on the sensor, and we can update that software, right? So part of that calibration can be done remotely. There are very rare cases, and we pretty much have done it never. But if required, those sensors can then be brought in. We do the calibration here, we send them back, and because it's a wireless plug and play sensor, it can then be easily deployed by the team on the ground itself without you having to send someone.
सर कमेंट लिस्ट दे देना.
Shyam Singh, please mute. Okay. So I think any other questions coming up? Otherwise, I will. Okay. No need for calibration, but if the manufacturing, you simply change it. Okay, which costs very less. So I will just talk about some of the future possibilities that the HVAC world is interested in. Two basic factors. This is a ISHRAE program, and I'm sure a lot of the listeners are ISHRAE members. And if they are not, they should become members. They will get many more programs like this. But all said and done, as HVAC engineers, whether you are designer or you are installer, you are into commissioning, you are into maintenance, you are into energy, any of these particular things, some of the things that have been a handicap is if you're a commissioning person, then, you know, the problem in the past used to be that we could not commission our plants using the BMS system that we were installing. You know, we had to, probably the BMS was the most incomplete part of it when the commissioning was going on. And the consultants of today, the younger lot, as well as the old timers, they would all like to see commissioning being done sitting in their office. That means when you start up the chiller, when you start up the air handling unit, whether the PID loops are tuned or not, that means if the temperature is going down, is the valve closing or not closing? Is it closing too fast? If it is a modulating valve, is it acting like a on-off actuator? These are the things that concern HVAC engineers. And if a commissioning is done right, and if you can watch it from a distance using this fast and easy IoT method, it would definitely add value to it. So Amarjeet, your take on this. How possible is it? How soon will it happen? When will the HVAC designers be able to see the proof of their product sitting in the office when commissioning is taking place? In other words, we will commission and record data using the IoT system that we install. What's your take on it?
I think that's a very good point, and I'll sort of touch upon a few aspects here, right? See, often when the building is designed, right, it is designed for the worst case. I mean, the HVAC system is designed for the worst case scenario, right? I mean, fully occupied building, June weather, especially let's say in Delhi, right? 45, 48 degrees of outside weather, fully occupied building, and that's how you commission, you provision the HVAC. Now, often most of the buildings, most of the time, are operating in not in the worst case scenario, right? But it's something lower, right? And that is where perhaps I think if let's say real-time data from the buildings that have been designed by designers and how they are being operated upon feeds back into the design philosophy, so that when you design things in the future, maybe you say that, look, I will design for 80%, 90%, and the remaining 10-20% is served with a different subsystem, right? But that doesn't account then for energy wastages, right? So maybe you create sort of, in a way, to create an analogy, do a multi-compressor AC rather than a single compressor that is running all the time, even if your load capacity is small, right? So I feel that this data is not just useful for those who are operating the buildings, but the data, if it can be fed back to those who have designed the HVAC systems for those buildings, can be immensely valuable for the new greenfield projects that are coming in. And for that, we need to create an ecosystem, and perhaps ISHRAE can play a role here, and where people like us would be happy to contribute into the ecosystem, where we bring in the end customers or the system integrators, we bring in the technology providers, we bring in the designers, all onto a common platform. We anonymize the data appropriately so that there are no privacy concerns, etc. But those anonymized data is then used to feedback into how the future buildings will also be designed, and not just operate efficiently the already designed buildings.
Right. I will just pose one more concern that HVAC fraternity has been having with these kind of things, or they have a need or want, is the coefficient of performance of first the chillers and then the air conditioning system. So coefficient of performance as defined is basically the kilowatt of cooling divided by kilowatt of power. And obviously it will keep varying on a system, and you can keep averaging it over a particular period of time. And you can have a cumulative number also every month or something like that. Now, can small subsystems be deployed on rooftops for just doing COP of chillers? You know, that is a very, very small thing. It's basically flow rate that is going through chiller or chill water system. Inlet outlet temperature sensors will then give the kilowatt of cooling that is taking place. And some of the monitoring systems on the electrical switchboard to monitor the kilowatt consumption during that point, and it will announce the COP. Somehow, you know, it's such a simple thing, but it has not been integrated by the manufacturers on their chillers. So what are your thoughts on it?
Yeah, I mean, I think I agree. I think what is, I think it's an ecosystem problem, right? I mean, that each, and that problem is actually sort of going away with time, but perhaps going too slowly, right? Many of the chillers, as we were discussing earlier, right, are now coming up with connected systems, right, where there are pump manufacturers, companies like Armstrong, right, that are creating connected pumps, right? There are Belimo now have valves that are connected valves, right? So there are these connected versions of products that are coming in. OEMs are being open. Having said that, I have also seen this tendency that these OEMs sometimes are open, but they want to create a closed ecosystem around their connected equipment, and they may not share that data openly over APIs for a third party to come in and integrate with themselves, right? I think that is what is my bigger fear, that if, let's say, I mean, in the older world, there was always a Modbus or a BACnet that standardized it. The moment you go to the IP-based world, and if OEM start saying that it is my data that will communicate over a proprietary channel only to me, I think that is where, as a customer, we all need to be educated and say that, look, when we buy an equipment, especially if it's a connected equipment that talks over IP-based network or APIs, we ensure that the vendor commits to opening up those APIs, right, to a third party, so that an ecosystem can be created and the customer can benefit from that connected equipment.
Correct.
Right?
And I think this is something that organizations like ISHRAE and all should take on board, or manufacturing organizations like Rama and all can take on board. But it is a common thing, so a common body has to play a role in it. because at the end of the day, this is all going towards better operation, better control, better energy saving, better COP values, not operating at persistent part loads and things like that, which cost a lot more money. And things are opening up. Okay.
And by the way, the OEMs themselves also benefit, right? I mean, think of it this way, that eventually, let's say a pump manufacturer is selling a pump via some of their distributors who are then eventually going and installing those pumps. If by opening up the APIs, they are uh, they are ensuring that those pump installers actually now get real-time visibility into how the pumps are being operated upon, right? And they can actually now go to the customer at the right time to either service or perhaps even get those pumps replaced. So it is actually in the benefit of the OEMs themselves also to open up these APIs, open up the data so that the field maintenance, and eventually at some point after 7, 8, 10, 15 years, whatever is the life of an equipment, and beyond that, new technologies anyway have evolved such that replacing an equipment may make more sense than continue to operate it even if it is working fine. They themselves create those insights and data that can help them eventually sell to the same customer in the future, right? So it's in the benefit of the whole ecosystem if we have these open APIs coming from these connected products that OEMs are now selling.
In fact, in fact, I will mention that as much as it is beneficial after so many years, it is always beneficial when you start the project also. Because
Right.
at the end of the day, a project execution is translation of design onto the ground. And calculation of pump heads is a very, not a difficult thing, but it's something that doesn't get done very much in the industry upfront. So you have both the situations, more of the situation that the pump head calculated was much more than what it exists. So you're operating at a much lower head and you are operating with a much larger flow rate and you are spending far too much energy into your pump than what you require. Okay. And that in turn creates what we call the delta T problem also, because you have too much flow rate, you have much lesser delta T in that particular case. So the system does not really get commissioned as it was envisaged by the designer. And if you correct that situation upfront, like what with the data that pump manufacturers are capable of providing today, you can immediately say this pump is really not operating the way I wanted it to. Okay, take a corrective action and you will save so much energy over a month or over its working life. So even that is very much required. Same thing applies to air handling units. Our air quantities being delivered at times are much more as compared to what we want. And really the changing of pulley or adjustment of pulley to bring down the RPM does not take place. And it keeps consuming much more power over the life of the equipment. And today,
Hello.
Yeah, I think we lost Mr. Goel again.
Okay. Well, sir, can you hear us? Anyway, I think, sir, all the question has been well taken.
Yes.
Is there anything left? What I think I don't see any question is left.
Yeah, I think all the questions have been addressed, Tapas. So, I
Yeah.
mean, if there are no more questions,
Mhm.
we can
Anyway, if you have any participants have any question, then your email ID is being displayed here, and you can directly send the mail to Singh sir in amarjit.singh atgenetics.com to at genetics.com, or you can directly mail to us also in Delhi chapter ID admin@dcsra.org, what we have shown in the flyer, and we will keep forwarding the queries to Amarjit sir. So you have the option.
And this video
Yeah,
will be shared on YouTube, right?
yeah. This will be uploaded on YouTube soon, within 10-15 days.
Okay.
So coming to the end, I mean, any final message you would like to share? Yeah.
No, I think I just iterate one final thing as what Mr. Goel has been saying multiple times through this presentation, that just try it out. Whether you want to do pure monitoring, you want to do only a small zone, you want to try it out in a small building first, you want to try it out with a friendly customer. I think if you haven't yet deployed an IoT based system, if you have multiple buildings, try it out in one building, part of the building, whatever, right? But try it out. The proof lies in the pudding. I can give you guarantees that once you see the benefits for yourself, you will scale it up. And we have seen it across pretty much all the customers we work with. They start small, but eventually pretty much everybody scales up to 100% of their square footage. So just do your bit, try small, try something, and I'm sure you will get addicted to the new technology.
Yeah, thank you, sir. And I think the webinar workshop has gone very well. And the thing is that we have received so many questions, and as you said earlier, we have to make this session interactive. And I think we succeed in this matter.
Yeah, thank you, Tapas, and thank you, Delhi chapter of ISHRAE, for giving us the opportunity.
Yeah.
Especially
So I think,
on
sir,
this
this is one of
important
the topic we can explore more also. I mean,
Sure.
just a minute,
I
sir.
think
Yeah.
Google is bad.
Yeah. So we can take further more session. I can, if you have time in future. So it was really a great session. Goel sir is now
Yeah.
connected.
So sorry for another
Not an issue,
power
sir.
failure. It just happens for 1 second somewhere down in the modem chain. I think I need to go down and install many more UPSs in that particular chain so that the modem doesn't go off. And yeah, these are the realities in India. And I think we are well tuned to take care of these things also, because I was always there on the listen mode. I don't like to keep two on the panel mode because otherwise they would reverberate. But I was always there on the listen mode. So all the best to the participants. I'm sure there are a lot of youngsters. And my parting advice to them is that whether you are a mechanical engineer, electrical engineer, communications engineer, or even a hotelier for that matter, get on to it, because this is tomorrow. You know, just like people got onto the cell phones and got onto social media, similarly, a bit of automation, a bit of data collection, a bit of or a lot of understanding of energy that you consume, and lowering your energy bills and in turn saving the environment will mean a lot to you guys on yourself rather than to us. So get on this and do the best that you can, and we will try and hold your hands wherever possible. And in this webinar itself, we sort of found out that some people have interest in getting on to programming IOs if they can, and we will try and bring out some training programs towards that. So thank you very much from my end, and goodbye and good luck. Over to you,
Thank you very
Amarjit.
much. Yeah, thank you very much for your great message. As we are discussing with Singh sir, for this topic we will explore in future as well, because many of the questions we have received, and that shows that how interesting this topic is. And as we are discussing that, we had discussed we will make this session interactive, and it was, I think, we have succeeded in this also. Uh, Coming to the end, uh, first of all, I am grateful to Delhi chapter of ISHRAE that I got the opportunity to for vote of thanks for this session, having great speaker today on this topic, IoT based BMS for energy efficiency in hotels. Before that, I request everybody, one who is non-member of ISHRAE, I request everybody to join, because membership is our strength, and ISHRAE has the only and all supermost priority to disseminate knowledge. And if you have more member, we'll able to reach more. And I mean, very nominal fees are there for joining the ISHRAE. I have shared the link in chat box. That is, you can click on that, www.ishraehq.in, and we'll find that there are two segments basically to ISHRAE memberships. One is for 3 years, and second one is for 10 years. And respective fees are also there. Just you will have to put over there after clicking this, Delhi chapter of ISHRAE, or one the most suitable chapter for you, because one is the nearest one you can deliver us will be more useful for you. But now the time is the virtual world, hybrid world. So Delhi is one of the chapter who makes more than 120 programs in a year. So definitely this will favor you in terms of knowledge, in terms of networking, in terms of reach, in everything. So finally, I would like to thank on behalf of Delhi chapter of ISHRAE, both the speaker for the day, Mr. Amarjit Singh, great speaker, and Goel sir, always one of the veteran person of ISHRAE. Everybody knows him. So nothing much to say, sir. Everybody know you, and your support for the Delhi chapter of ISHRAE with us, he always there, and will make this kind of program in near future also. We are thankful for all the partners we have for Delhi chapter of ISHRAE, who supports each and every step for Delhi chapter of ISHRAE, and that is platinum partner Armacell, gold partner LP Aeroflex, silver partner Briar TRI, Syscam, Advanced Valve, and annual partner Standard Refrigeration and Paramount Polytreat. And of course, without the attendees, we cannot make this kind of program. So we are thankful for all the attendees, all the participants, all the person who asked the questions and make this program interactive, and all the CWC member and DCI staff as well. So thank you very much. Thank you for being with us. And another program we have in 4:30 also. So I request you to join also. We have shared the link in all the email that for the members and non-members also. So thank you very much. Thank you.
Thank you, everyone.
To Siddiqui sir with us, coming to join. Yes. Hi, Siddiqui sir, can you hear us? Siddiqui sir, can you hear us?
Yeah, I can.
Yeah.
I can. Yes.
So yeah, actually we have at the end of this session. So any final message you would like to share in this forum, and then we will close.
Yeah, I think this has been a great session, the great workshop, and let's look ahead to utilize the information and the experiences that have been shared by the two eminent speakers. And further, for any questions or any other information required, can be contacted on the on the to the panelist or to ISHRAE Delhi chapter also. So I think that's it. And let's take a pledge today. That's the very important thing. Let's pledge today to save the earth, because today is the Earth Day, and
Yes.
save the environment, save the ecology. Whatever we can do, let's plant more trees. Let's take a pledge. I'd like everybody to take a pledge today.
Yes.
I think that's it. That's the motto today.
So thank you, Mr. Siddiqui. Have a great day.
Yeah,
And we will
thanks a
sign
lot.
off.
Thanks a lot.
Thank you,
Thanks a
sir.
lot.
Thank you, everybody. Thank you.
Bye-bye.
So with your permission, I'm closing the session, sir, for the day.
Yeah. Thanks a lot.
Thank you. Thank you, everybody.